Today we're going to be talking about the chain rule. So what is the chain rule? Well, if we have a function g of u where u is equal to f of x, that can be confusing, but just bear with me. Then dy dx is equal to dy over du multiplied by du dx. This is important and enables us to differentiate complicated functions much faster without having to do some more complex math. So for example, if we have a function to the power of something, then dy dx is just equal to treating that function almost as similar to as just an x, where we decrease the power of the function and multiply the function by the power. And then we multiply it by the derivative of the function to begin with. We can often write complicated function as the composite of two or more simple functions. So for example, if y is equal to x squared plus 3x to the power of 4, we could write it as y equals u to the power of 4, where u is equal to x squared plus 3x, and then we can just differentiate them separately and then add them back together. Let's try a really easy question to begin with. So we just talked about this one. So find the dy over dx of x squared minus 2x. So we first have to think what is going to be our u and what is going to be our g. So in this case, because the function is to the power of 4, we're going to let g of u be equal to u to the power of 4, and u is going to be equal to x squared minus 2x. So now the next step will be to differentiate them separately, and then add them back, and then multiply them to get the final dy dx. So you can see on the top right in the green square how we did this. So we differentiated them separately, and then we just multiplied them at the end. So the product rule is similar to the chain rule. It allows us to differentiate complicated functions much more easily. So this is used when there is a function multiplied by another function. So when if f of x is equal to two functions multiplied together, in this case u of x and v of x, then f prime is equal to the differentiated u of x multiplied by the v of x plus u of x multiplied by the derivative of v of x. Alternatively, if y equals uv, we can say that dy dx is du dx v plus v dv dx. This is quite simple mathematics to get your head around, but sometimes it's very hard to do some questions, so let's try some. If we have to find dy dx of y equals square root of x multiplied by 2x plus 1 to the power of 3. So now let's see what we have here. We have a square root of x multiplied by a 2x plus 1 to the power of 3. We might have to use the chain rule as well as the product rule in this case. So let's use the product. So let's say u is equal to x to the power of 1/2, because square root of x is the same thing as x to the power of a half, and v is equal to 2x plus 1 to the power of 3. So first, we're going to use we're going to differentiate u, which is pretty simple. We just multiply x by 1/2 and then decrease the power by 1 to get negative 1/2, and the v prime is just going to be 3 to the we're going to use the chain rule for this. We're going to say put the power down 3, and then we're also going to take out the 2 from the 2x because of the chain rule, and we're going to multiply that as well, and then we're going to take the whole function 2x plus 1 and multiply it to the power of 2 because we decreased the power from 3, and then we can just simplify. Now we have to add them two together using the product rule, which just gives us this equation, which I will not read out, but So the quotient rule is another rule of differentiating that just helps us differentiate more complex functions. This is used when we are dividing two functions. So we can say that if q of x is equal to v of x over u of x, then q of x is v prime of x times v of x minus u of x times v prime of x, all divided over vx squared. This might be hard to memorize, but after doing some questions, you'll get it. Let's now use it to try to find the dy dx of the following function: 1 plus 3 over x divided by x squared plus 1. So first we need to realize which one is u of x and which one is v of x. In this case, the top one, in every case, the top one is going to be u of x, so 1 plus 3x is u of x, and v of x is x squared plus 1. And then we're going to differentiate them separately, and then we're going to add them back together. That's not for the rules of differentiating. Next time we're going to be differentiating exponent functions, derivatives of logarithmic functions, and derivatives of trigonometry functions.